Hello all, I am R Puttalingaiah, CBM Specialist and Product Manager at Infinite Uptime. In this video, I will simply explain how to start the predictive maintenance program. Before applying our predictive program, let's understand the sources of production losses in a company. In an independent study, it was determined that mechanical failure is the single greatest cause of process interruption. Most often, it is preventable. With this information in mind, you need to consider the machines that are critical to your factory's production. These critical machines should have greater priority over the other machines and dictate how much time you should consider for monitoring them regularly. It may not be possible in an ideal world to take the traditional approach for such high frequency schedule to monitor them. Infinite Uptime IoT-based predictive maintenance solutions solve this problem. If you choose to monitor critical assets every 6 months, then might as well turn this video off and put predictive products in the trash, because it doesn't make any sense if you monitor these assets by a huge delayed frequency. Let's understand categorization of machine types. In any industry, we can broadly categorize machines in 5 groups. First, critical group. These are equipment that your factory production or operation depends on. If this equipment fails, production stops. Second, essential group. Equipment that is highly important to factory operations. Failure may not cause an immediate work stoppage, but production may be impacted. Third is important group. Equipment that affects the quality of the product produced or which is in continuous operation and for which no backups exist. Fourth, secondary group. Equipment that is run in backup condition. Now, with Infinite Uptime's IoT-based devices, it's economically ideal to measure them every week or even daily as required. You also need to understand what the vibration data analyzer or collector consists of. Take an example with Infinite Uptime's IoT-based predictive IDE. It consists of an integrated triaxial vibration sensor, temperature sensor, and a sound sensor. This comes along with its magnetic base, which eases mounting applications and can also come with stud mount arrangement for permanent mounting techniques. It has a power cable with a 5-volt power adapter. This is how it looks. Now let's understand how it works. The IDE needs to be mounted on the selected machines for each bearing location in the assets permanently. It needs to be configured to the available Wi-Fi. Through Wi-Fi, the IDE starts sending the data to the cloud. Through a web browser based software, access the data and analyze it for better prediction. To be more precise, it has 6 basic steps. Installation of IDE on the selected assets. Configure and capture vibrations, temperature and acoustic. Observe normal vibration. Set threshold limits. Compare capture data with thresholds. And detect any discrepancy to alert authorities through SMS and email. There are also a few considerations that need to be kept in mind. Understand the equipment and its application. Recognize the changing conditions. Choose the best shot at capturing the event. Choose the best sensor for the job. Choose the best location for the measurement. Make appropriate settings for the measurement. Capture good quality of data by applying proper mounting methodology. Transfer data into actionable intelligence. Identify telltale signs of trouble. Decide a course of action. It is also very important to choose the best location for vibration data collection. Ideally, it should be closest to the bearing location. Machine vibration may be in any direction depending upon stiffness and damping characteristics. As shown in this diagram, Horizontal location is always chosen in a position where stiffness is weak. We need to monitor in all three locations for each bearing location of the component. Or, easy still, choose an IoT predictive device to measure all three axis data together. In general, for a detailed study of vibration dynamics of any machine, vertical, horizontal and axial data at each bearing location is mandatory. When only monitoring is needed, 1 point per bearing and addition of axial when there is a thrust bearing or axial when potential faults like misalignment might occur. Once the measurement points and locations are decided, then we need to set the threshold for the measurement for better exceptional reporting. We can decide these thresholds by applying this methodology. Use technical associate standards, use ISO 10816 or use OEM specifications. The machines that cross thresholds will call for a detailed analysis. We can do this by studying the spectrum analysis. Each faults in the machines will be behaving or having different frequency patterns. For example, specific machine faults will generate 1x harmonics. Over the period, it will generate harmonics that are 2x or even 3x. Along with this, if the sensor is mounted on the gearbox, it will generate gear mesh frequency with its related faults along with harmonics. Bearing frequencies issues also start from high frequency band. All these problems can be well studied and analyzed through spectrum analysis. This helps any analyst to take the suitable decision on maintenance. Hope this was helpful. Thank you for watching this video.